So using a breadboard, we now have a circuit that's going to be permanently on. We have over here in this GPIO pin over here, which is the top left one, this is 3.3 volts of power, which flows over here directly into my row number 2. In that row number 2 over here, I then have my transistor, which is flowing up and over into the same horizontal row, but across the spread of the breadboard over here. And then in that same horizontal row, in that LED light over here, we have the positive leg of the LED plugged in. The positive leg is the longer of the two legs, so that pin needs to go into the same row as our transistor, which is reducing the electricity. Then over here with our LED, the shorter leg over here is in the same row as my ground wire. So a lot of people by accident have this ground wire right below our little LED lights, but that's not going to turn it on because the rows are connected horizontally. So it has to go in the same horizontal row over here. It doesn't matter if it's in this one, if it's in this one, if it's in this one, they'll all turn it on. Heck, it could even be on the other side because they're all connected. So once that's plugged in, we've created the circuit, but this is permanently on. We want to make it so it's not permanently on, so what we're going to do is on a Raspberry Pi, instead of using 3.3 volts of power, which is over here in the top left row, we're going to unplug this, which will terminate the circuit. It will no longer be plugged in, and we're going to put it in a general purpose pin over here, number 17, which if on the left side we count down 1, 2, 3, 4, 5, 6, it's the 6th one down over here. So by plugging that in, the circuit is not currently turned on, but what we're going to do is we're going to turn it on using our computer over here. So we're going to, using software, physically turn on this LED over here. So what we're going to do is we're going to go to the menu over here, the top left, the Raspberry icon, and we're going to open under programming an app called Thonny over here. And in Thonny, you're just going to write from GPIO import LED. So this is a library for the GPIO pins, the general purpose input output pins. And we are importing the LED library. And we're going to say that the LED is equal to LED 17. Why 17? Because this pin over here is considered the pin for the general purpose input output number 17 on the map, which I'll overlay. Then I had written LED off just to turn it off, but if I were to change that over there to LED.on, and if I were to run this program over here, what's going to happen is when I click run, which is going to be right now, my LED should turn on over here.